Hello students, let's try to evaluate this integral by evaluating the residue of this given problem. Now the detailed problem is, let S be the positively oriented circle given by mod of z minus 3 iota equals to 2. Then we have to evaluate the value of this integral 1 upon z square plus 4 dz. Now the first step to solve this is we have to evaluate the pole of this function. This function fz equals to 1 upon z square plus 4, where z, this circle is defined by mod of z minus 3 iota equals to 4. Now to calculate pole, we simply equate this z square plus 4 equals to 0. That simply means the value of z will be 2 iota and minus 2 iota, that is plus minus 2 iota. Hence we have the poles of this function fz is 2 iota and minus 2 iota. These are simple poles. Okay, since we are given with this circle, that's why this minus 2 iota we will drop it because it does not belongs to this circle. So we will evaluate our residue only at this value, that is z equals to 2 iota. We have to calculate our residue at z equals to 2 iota. Now as we know that the residue is calculated by b1 equals to limit z tends to z0 z minus z0 into f of z. Now this b1 will be limit z tends to 2 iota z minus 2 iota into this 1 upon z square plus 4, and this z square plus 4 can be written as z plus 2 iota and into z minus 2 iota. That is, the value of this b1 will be limit z tends to 2 iota 1 plus z plus 2 iota, which will come out as 1 upon 4 iota. Now, or this is your Laurent expansion, where fz equals to summation where n runs from 0 to infinity a n z minus z0 to the power n plus this summation of where n runs from 0 to infinity bn z minus z0 to the power minus n. I am just here giving you the quick review of this Laurent expansion, as it will give us that how to calculate the integral with the help of a residue, where an equals to 1 upon 2 pi iota integral of f of zeta upon zeta minus z0 to the power n plus 1 d zeta, and bn equals to 1 upon 2 pi iota f zeta upon zeta minus z0 to the power minus n plus 1 d zeta. Now the residue is our b1, means when we replace this n by 1, we will have b1 will be 1 upon 2 pi iota integral of f zeta dz, as this term will come out as zeta minus z0 to the power 0 equals, that will come out as 1. Now this will give us the formula that this integration, see, f zeta d zeta will be equals to 2 pi iota into b1, that is your residue. Now we will apply this formula to evaluate our final result. We have residue was 1 upon 4 iota, and the final result will be 2 pi iota into sum of residue within S, and it will come out as 2 pi iota into 1 upon 4 iota, that will come out as pi by 2. Hence the value of this integral will be equals to pi by 2. This will be our final answer.